Topic 0 is going to allow us to kind of revisit some basic math skills needed to be successful in Honors Algebra 2. This topic will allow us to kind of get used to the processes that we follow in class and help us prepare for further topics. Lesson 0.1 is titled Simplify Expressions and Solve Equations. Hopefully this looks pretty straightforward to you and you remember doing some of these things in either Algebra 1 or Geometry. Let's first take a look at some key points on the left-hand side. Order of operations. The order of operations is used to simplify expressions. You may have heard the mnemonic device Pemdas, P-E-M-D-A-S. P stands for anything that's in parentheses, so you always kind of want to work inside out. Then you'd follow by anything that has an exponent. M stands for multiplication. Whoops, we already have an M though. We don't need that M twice, do we? Multiply and divide. And you just want to go in order from left to right in that process. So you may be doing some multiplying and dividing, kind of one after the other, from left to right. Last but not least, you would add and you'd subtract. Wow, I did that the same both times, didn't I? You add and subtract from left to right. Let's put that to the test with a couple of examples. Simplify the following expressions. What I want you to do is actually pause the video and try that first example. See if you can follow all those negative signs, the parentheses, and that exponent. Once you think you have the right answer, press play again and we'll see how you did. Did you get negative 16? If so, you followed the correct order of operations to simplify. If not, let's take a look at the steps that I did to simplify. I recognized not only did we have parentheses, but we had an exponent. I took 1 minus 5 and got negative 4, and I kept it in parentheses because of the subtraction in front of it. When I had minus negative 4 squared, I did that negative 4 squared first due to order of operations, and I got minus a total of 16. The double negative in the middle made it negative 4 plus 4 minus 16. And 0 minus 16 stays negative 16. Let's give that second one a try. Again, the more you can do independently, the better off you'll be prepared for your Savas Realize assignment. Pause and try the next problem, then press play, and we'll see how you did. By chance, did you get negative 6? This one was kind of tricky. There were lots of parentheses. If you worked inside out, I recognized that negative 2 plus 1 was equal to negative 1. That eliminated that innermost parenthesis, but then we had negative 16 minus negative 1, which that double negative changed to plus, and I got negative 15 times 2, which was negative 30. Finally, I did the divided by 5 on the outside of the parenthesis and got negative 6, using the order of operations to simplify expressions. Now, if we're asked to combine like terms over on that left-hand side, find matching terms, meaning the variables are identical, and then simply combine their coefficients. Hopefully you can get all that to fit in there. There we go. Now on the right-hand side, we just have one example to model this. It says combine like terms. If we just go from left to right, I notice it's all addition and subtraction. Yes, we have an exponent, but we're not going to evaluate that exponent for a number base. It's with that n, meaning it's n squared. If I go from left to right, I see negative 10n. What that means is n is my term. Anything else that has plain n in it is a like term. Negative 10n minus 5n more would give us a total of negative 15n. What I'm going to do is cross them off and then move on to the next type of term. I notice the next term is n squared. And that's the only term in that expression that has an n squared. That will stay as is. I see we have a 3m, but there's no other plain m term. I'll write that as 3m. Then I have mn and another mn. That would mean it's negative 2 plus 1, which means it would be negative 1 mn or minus mn. And then we have a constant of negative 1, and that would just put us at minus 1 at the end. There's no standard form to put this in or any particular order yet, so you can write them in any order as long as your coefficient matches. Finally, when asked to solve equations, what you're looking for is isolating your variable. So we want to isolate the variable on one side and get everything else on the other. And we'll use our order of operations kind of in reverse to make that happen. You'd want to get rid of anything that's being added or subtracted to the variable, and then anything that's being multiplied or divided. So maybe throw that in here, kind of like the reverse of Pemdas. Let's see how that works. We'll start off with an easy one, and then we'll kind of work our way up with level of difficulty. 2/9 y minus 8 equals negative 6. Our variable is y. That's what we want to isolate. So if we're going to do reverse of Pemdas, you'd want to get rid of anything that's being added or subtracted. If it's 2/9 y minus 8, we'd move minus 8 to the other side by doing the opposite operation. We'll add 8. That gives us 2/9 y equals negative 6 plus 8, which is 2. And if we multiply a number by the fraction, instead of dividing by the fraction, let's multiply by its reciprocal. If we multiply both sides by 9/2, the 9's cancel and the 2's cancel in the same step. Over on the right, that first 2 in blue is the same as 2 over 1. Notice the 2 on top would cancel with the 2 on the bottom, and we end up with 9 over 1, which is 9. We've isolated the variable. Now the rest of the problems have parentheses and quite a few things happening there, but we're going to apply that same idea. Let's take a look at the example on the right. We have 2 times x plus 4 over 3 minus 8 equals 32. Again, let's think about Pemdas, but backwards. The first thing we want to do is get rid of anything with that variable that's being added or subtracted, but there's a parenthesis that has adding in it as well. We'll work on that last because parenthesis is towards the top of Pemdas. We'll start simply by moving that 8 over again, just like last time. If we have 2 times x plus 4 over 3, 32 plus 8 is 40. We also have that fraction again. So just like last time, I'm going to multiply by the reciprocal of the 2 and the 3. I'll multiply both sides by 3/2. The 2 cancels with the top, the 3 cancels with the bottom, and look at that. All of a sudden, we simply have x plus 4. On the right, 2 goes into 40 20 times, and 20 times 3 is 60. Last but not least, now anything that's happening to x, we'll move 4 over by subtracting, and we get x equals 56. There we go. We've isolated that variable. I'm going to let you try the next one. See if you can get x by itself. Press play when you're done, and we'll see if we get a match. Well, how did we do? I got x is equal to negative 11/20. Notice it's not a decimal answer. It is in fraction form. On Savas Realize, you will not be allowed to give a decimal equivalent unless it says so specifically in the directions. Let's take a look at what I did if you did not get negative 11/20. On that right-hand side, the first thing I did was simply combined like terms. Recognizing that that 1/4 could be moved to the other side by multiplying the reciprocal, I did that second. Now, if you choose not to move that 1/4 over, you could distribute it in. You'd still have to deal with some fractions, but end up with the same answer, and that is absolutely okay. But what I did was simply eliminate the 1/4 on the left-hand side by multiplying each side by 4. Then I had 4x minus 1 equals negative 16/5. If I moved the 1 over by adding, I had to get a common denominator, and that's where that 5/5 comes in. I took negative 16 plus 5 and got negative 11/5. Last but not least, I had to get rid of that coefficient of 4, And since there's a fraction on the right-hand side, I wanted to keep a fraction on the left-hand side. I multiplied by 1/4 instead of dividing by 4. And I ended up with negative 11/20. All right, let's try this last one. We want to get t by itself, it looks like. That's our variable. But it's in fraction form, and we have t in a second fraction. So what we'll have to do on this left-hand side is figure out a common denominator. What do both 2 and 10 go into? Denominator, there's an A right there. There we go. They would both go into 10. What that means is we can keep 7t over 10 the same. And for t over 2, if you multiply the top and bottom by 5, that would be 5t over 10. And now we have a common denominator. 7t minus 5t, we just combine the coefficients, would give you 2t over 10 equals 1. To get t by itself, there's our reciprocal again. If we multiply by 10 over 2, the 2's cancel and the 10's cancel. T would equal 1 times 10 over 2, and 10 divided by 2 is 5. There's lesson 0.1. What you'll do for here is answer a couple of quiz questions and then upload a picture of your notes onto Schoology for credit.